Okay, this is what you should have seen. If my earlier explanations weren't clear, this is what you should have ended up with. So if I take a random spot, let's say over here, why is this a 1? Because if I was the first player, it was my turn to play, and I was right here with this many tokens. These tokens over here aren't here, so I'm here in this position. If I remove 1, that person now is in a losing position. Right? That's all I need, is I need to move them to a losing position. That means I can win in this position. Let's suppose I'm here. Well, I could remove 2, and then it ends up, the second player ends up in this position, which I already know is losing because I've already figured that out. So these 2 positions are 1. Why is this one 0? Because if I start at this point here and I remove 1, now my opponent is in a winning position. I already labeled this as a winning position. If I remove 2 of them, my opponent is in a winning position. So this is a losing position. Is it clear? If it's not clear, clickers go down. Not clear? One more time, explain it. One more time, clear? Okay, clear? Anybody else?
I'm good, but we also found that, or we said, I don't know if you said this yet, but every multiple of 3.
That's right.
Is you want to get it to be your opponent's turn at every multiple of 3.
Right. So player 1 can win with 17 tokens because by pushing player 2 to the green spot by removing 2 tokens.
Does this work for every interval or just 1 and 2?
Well, I'm going to ask you that. Right? The pattern repeats, or we say it's periodic. That's the math word we use. Periodic of period 3. It repeats in every 3 terms. So, the question you just asked was a good question because I thought of it too. Just use 10 tokens. You don't need to have 17. I think you can see that this idea will work with any subtraction set. I could still do this backward induction. So if I had 10 tokens, try it out and do as the same thing you did with s equals 1, 2, but try, so this is what, I have a table here. Fill out the table for some other subtraction sets. Here's the other subtraction sets, 2, 3, 3, 5, 2, 4, 2, 6. And see if it drops into a pattern like you just saw for 1, 2. In 1, 2, you saw that it repeats with period 3. What if you use 2, 3 instead? Are you going to end up with a pattern? Yes or no? If it does end up with a pattern, what's the period? The idea is if you can figure out a connection between the period and the subtraction set, then you really can mess with the other person, right? You don't like 1, 2, let's use 2, 3, right? You pick the subtraction set. In fact, I'll be generous. You pick the subtraction set.
And you go first.
What do you mean by cycle?
You pick 2.
Does it go like we did 1, 1, 0, 1, 1, 0? Is that going to be right away, or is it going to bounce around for a little bit and then start repeating?